Your warm-up asked you to find the value of each variable that makes the statement true. So let's go ahead and begin. To find the value of a variable, we need to isolate it. We need to solve for it. So that means that we need this a variable all by itself. So first of all, this a variable is part of the 2a term. What I can first do is get rid of this 6. So if this is a positive 6, the opposite to eliminate it would be a negative 6. So I'm going to subtract 6 from both sides. This eliminates because 6 plus negative 6, or 6 minus 6, is 0. So I'm then left with 2a equals 0 minus 6 is negative 6. My last step, so this was a two-step equation, is to, if I currently have 2 times a, then I need to use the opposite function. So instead of multiplying by 2, I'm now going to divide by 2. Sorry, I almost wrote a there, but we're dividing by 2. And what I do to one side of the equation, I must do to both sides. So if I'm dividing this side by 2, I'm dividing this side by 2 as well. 2 divided by 2 is 1. So this is like 1a, which is the same as just saying a. We don't need that 1 in front. Then negative 6 divided by 2 is equal to negative 3. So we have solved that by a two-step equation that when we have a as negative 3, this equation holds true. Next, here we have 7 times b equals 0. If we need to isolate b, and we currently have b being multiplied by 7, my inverse operation would be to divide by 7. So I need to divide by 7 on both sides. 7 divided by 7 is 1, so I'm left with 1b, this single b, equals 0 divided by 7, which is 0. Another way I want us to think about this, that's going to be very helpful for today, is here we have two factors being multiplied, and their product is 0. Anytime something is multiplied by 0, the answer is 0. So the only possible thing to multiply 7 by to have the answer as 0 would have to be 0. Again, anytime we have an answer as 0, one or both of the products, the numbers being multiplied together, must be equal to 0. So in this case, we knew b had to be equal to 0 without even doing this operation. Here we have 7 times c minus 5 equals 0. Using the same concept from above, here we have two products being multiplied. We have 7 and we have c minus 5. This is considered one factor. Sorry, we have two factors being multiplied. This is considered one factor because the whole thing is inside the parentheses. And when we have a product of 0, an answer of 0, one or both of the factors have to be equal to 0. Clearly, 7 is not equal to 0. But that means 7 must be currently multiplied by 0 to equal 0. That means everything inside this parentheses must be equal to 0. So I would have c minus 5 equals 0. And we could also see this, that if we did do the opposite, instead of multiply by 7 here, divide by 7, on both sides we would get c minus 5 equals 0. And then we need to go ahead and solve. So if I'm isolating c, I need to do the inverse operation here. So instead of subtract 5, I need to add 5 to both sides, and I get c equals 0 plus 5 is 5. I can check that because I know if I plug 5 in here, 5 minus 5 is 0, and 7 times 0 is 0. Same thing here, 7 times 0 is 0. So c has to be equal to 5 to make this equal to 0. And lastly, g times h equals 0. We don't have much to work with here, but we do know that one or both of the factors has to be equal to 0 if we're multiplying them together and their product is 0. So we know that g is equal to 0 or h is equal to 0. It could also be both. It's possible that we have 0 times 0, which is 0 here. So I'm going to add a little and. It's got to be g or h or both are equal to 0. And those are your solutions to the warm-up.